Hello, so welcome back with the same topic of hydraulic. So I'm going to talk about open channel flow again. Um, yes, there's still six more problems of the previous chapter that I haven't finished yet, but I think this is more important to finish the open channel flow because I think they're more easier and um, like it's more simple than the one in the previous chapter. So if you guys remember, the previous chapter was about um I forgot what it was about. Yeah, the previous chapter was like a little bit harder than this one. The pipe flow and stuff. Yeah, so as this one I feel like it's more interesting, like you can apply in real life in the future. Okay, so now we have a problem that a prismatic channel. So from the previous video that I've done, the summary of the summary of the lesson of the chapter. We have the channels, right? We have different kinds of channel. We have circle, we have rectangle, we have triangular channel, and we have trapezoidal channel. Actually, it was like this because and many other things. So in this case, this is a prismatic channel. So this prismatic channel, I will like draw this picture for you. It looks somehow like this. It's a combination of you know rectangular and triangle, rectangle and triangle. So basically, this would be somehow in the center, and this it is given in the exercise as 30 degrees. Okay, so it will be better for the computation if it's giving in degrees, and this is in height. Yeah. Why is it not working? Okay, imagine it's perfect. So in this case, they gave us the symmetry cross-section shown carries water at the rate of 1.5 cubic meter per second, and the Manning's N is 0.2 m a meter. This is the unit, and the streamwise slope is 0.1. So we highlight all the numbers that we need to use in the calculation. So the question is how to find the normal depth and relative to the lowest point. So the lowest point is the bottom here, and the fruit number at the normal depth and the critical depth. So we have to find two depth and the fruit number because fruit number can be applied when we have to find the critical depth later. So basically, in order to find the normal depth here, we need to know, we can use the Manning's equation, and then we can find the depth here in so in our h here, we have a over p, right? And in a over p, there is a common h. So we're finding h from this equation. So now let's try to break down the components. So it's just in case this is supposed to be in the center, somewhere in the center here. I think it's not in the center. I think this one is longer, but this and this supposed to be equal, right? Okay, so I'll draw it on this one so we can be precise. So let's say this is 6 like this. I'm not sure how much is 30 degree, so I'll just say it's something this way. And then we have, this is not okay, so this here is the channel, only here, and this is the ground. Okay, so this is the height. It's 0.8 meter here, and this is 30 degree. Okay, so we need to find the base and the hypotenuse in order to compute for the perimeter. So in this case, we need to find this base, right? Okay, so if you look carefully, this base there is two base here, and this base here from here to here is equal to here from here to here, right? So the actual base of a triangle is 2 times of this base. Okay, so you can see that this is a triangle here, a right triangle. We have one 90-degree, and we know another degree is 30 degrees. And this is obviously at 60 degrees, but we're not going to use that value. So let's say the base here equals to 2 times the base of the little triangle here. So the base of the little triangle here, we know the height of this one, which is the opposite to the angle. So if it's the opposite 0.8, we need to find this one, right? So it's 0.8 times, I think this one is sine, right? Oh, not sine. Tangent of 30 degree. And then we have the hypotenuse, I would say hypo. It's this part here, right? Because we need to find the wetted perimeter. So the wetted perimeter is this one. So I will say it's also one side. So one side is 0.8 over sine 30 degrees. Because this is the opposite here, and we need to find this one. But previously we want to know this one, but we have this one, so it does not have anything to do with this one. Obviously it's the tangent. So this one, it has to involve with the hypotenuse and the opposite. So opposite and hypotenuse, of course, it's O over H equals to sine, and we need to find this one, so O over sine equals to H. Yeah. Okay, so now we can compute the A and P. So in this case, we need to find A, right? So A equals to 1 over 2 times 0.8 times 1.6 square root of 3. Yes, because tangent of 30 is square root of 3, right? And meter squared. And then for P, it's 2 times 1.6, because this one is equals to 1.6 meter. Okay, so then A is equal to 1.108 meter square, 3.2 meter. So after we find A and P, we can compute the RH, the hydraulic radius. So hydraulic radius is 1.18 over 3.2. This one is meter squared, this one is meter, and the answer is 0.346 meter. So then we can compute the U, the Manning equation. So Manning equation is square root of S over N, the Manning's number, or we can say the constant, Manning constant, times with RH overall with 2.3 times, oh no more times. So this is 0.001, because it was 0.1, yeah, 0.1%. So 0.1% is equal to 0.001. Everything here over N 0.02. This is square root. Then we times with 0.346 meter. Yeah, we have to write the meter here, but I just forgot it, so yeah, that's fine. 2 over 3 and the number is 0.782 meter per second. So we can then find the Q, which is the flow rate. So the flow rate here is UA, and UA is equal to where is U? Okay, U we just found earlier, 802 meter per second times with A, which is we found earlier, 1.108 meter squared, and the answer is 0.84644 meter cube per second. So meter cube per second is less than 1.5 cubic meter per second. That is given in the problem. So in the problem here, they said carries water at this rate. So the normal depth here is lower. It's lower than the in this case the water is flowing like this, right? So we can see that this is flowing over the V line here. So 1.5 here is like above this line, because this line can carry only 0.864. Yeah. So okay. So the water here can carry only 0.864 cubic meter per second, while up here, while the water is already 1.5, right? So it must be above the V line. And then we can find okay, so it is less than required, right? Then we can find the fruit number, but the fruit number here is not for the normal flow, because we're going to compute it with the given flow rate, and the depth is 0.8, right? So now let's start to, I'll change the color here. So we have to find the U, the velocity. It's equal to Q over A. And in this case, the Q is not this 0.8. We're going to use the actual required flow, and the A is still the normal A. So it's 1.108 meters squared. The answer is 1.353 meters squared per second. And then we can continue to the other one, which is find the hydraulic depth. So it's hydraulic depth, HD. Please don't confuse it with the other one that we have to find. The water, like there's a static height and that one, so it's HD is hydraulic depth. How do we write this one? Hydraulic depth equals to A over BS. So basically, hydraulic depth is the formula is not fixed. Okay, it depends on the situation. Okay, of course, like if it's so hydraulic depth and hydraulic radius is not the same. Hydraulic depth is, for example, it's a rectangle, right? So this is the depth here. Is actually equals to y is the hydraulic depth, but for the hydraulic radius, it's y over yx over something like for the perimeter, right? So of course, it's not the same. So don't be confused between the hydraulic depth and the hydraulic radius. So for A here we have 1.353 1.108, the same, meter square, and b here is equals to 2 times of 0.8 times tangent of 30. It's 2.771 meter. This is from here. The depth here is, yeah, this piece. Okay, and then we can compute the so it's already in different colors. Okay, so and then we can find the fruit number. The fruit number is FR equals to V over square root of GH. So GH D. And everything here, that we found here is u, velocity, 1.353, and this is 9.81 times, okay, forgot to do this. I'll say 0.4. So the answer is 353 over square root of 9.81 times 0.4, 0.683. Okay, so then we can see that 0.683 is less than 1. So less than 1 means that it's subcritical. Subcritical, it's like deep and slow flow. So if this one more than 1, it would be super critical, and if it's equal to 1, it's critical. So in this case, we can compute the actual fruit number for question B next, but in this case we're not going to the question B right directly because we have not finished question A yet. So from this question A, we need to find the normal depth that is greater than 0.8, because as you can see that if it's the normal depth here, it's going to be above, it's going to be, the flow is going to be above the V line. So in order to have it right at the normal depth that is greater than 0.8, we need to compute the following calculation. So then we can start computing the calculation that is the actual okay, so I will write that this here. Preliminary calculation. So then we're going to find the real calculation down here. So for the real calculation here, I'm going to use the blue color. We need to find well, since 8, the normal depth here is greater than 8 meter, therefore it's going to be something a little bit tricky. So area here equals to 1.108 plus the upper area above the triangle, right? So it's going to be h minus 0.8 times 1.6 square root of 3. So in this case, like you can see, this is the area here is 1.108. So we're going to find the area here. So this case is 8.8 here, and we don't know the area. We want to find the area here, and then we plus with this one. So then we can see that the area is like this, and we can simply write it as, oh okay, so this is the base, right? Yeah, as the base. It's 2 times 0.8 times tangent of 30 degrees. It's 2.11771 h minus 1.108. Am I right? Wait, so supposingly it's 1.108 plus, okay, 1.6 square root of 3h minus 1.6 times square root of 3 times 0.8. Two point 217, and 1.6 square root of 3 is 2.771 h minus, because this is a minus sign here, so it's 2.217 minus 1.108. So it's 1.109. And then we have p here. The parameter is too long, I don't want to write it, so it's the parameter, this parameter, and then we plus a little bit of here, a little bit of here. We don't know how long it is, so it's two side, right? So if there's only one side, it's h minus 0.8, so it's two side, just multiply by 2. So we have the previous one is, okay, the previous one is this one, and then we plus 0.8 h minus 0.8 meter. Okay, I want to have another line. 2.4 plus h meter. Oh, times 2, so it's supposed to be 1.6 plus 2h. Then we can find the q, which is, the q, which is u a, and u is equals to square root of s over n times rh 2 over 3 times a. So now we can see that the square root here is, how much is the square root? I forgot. Okay, this number here, 0.0001. Oh, what a nice parabola. 0.001 over 0.02 times, so basically r is from a or p, right? So a can be a factor inside this one. We can get a power 5 a power 5 over 3, and down here it's p power 2 over 3. Yes, so then we substitute everything here, but I don't want to substitute it yet. I want to calculate this number first. Divide by 0.2, it's equal to 1.581 times this one. It's 2 point, why am I pointing up there? 71 h, I'll say x, because in the calculator we're going to use x, minus 1.109, like this, meter square, and then we get everything here. Five over 3 Yep, and then we get P is 1.6 plus 2H 2 over 3. This is in meter. Okay, so then Q is equal to 1.5 cubic meter per second. So then we will solve for x using the solver in the calculator, in which you cannot see my screen of the calculator. But if you actually saw it in the previous video, I already showed you how to use the calculator solving mode. So I'm going to write 1.5 equal to 1.581 and type the following data here. So I actually pre-calculated it because it takes quite a long time for the calculator. I think it's because my calculator is quite old, or maybe because of the series, but yeah, I'm looking for a new calculator, so any support or donation are welcome. Just kidding. Okay, so for this one, it's like I already done the pre-calculation and I got H, because when you click it on the solve, right, the shift button here and the solve here, it says cal like this. So when you shift it like this, 1, 2, then the screen will show you something here, but it's not the answer. You need to click on the equal button again, and you can wait around like 5 seconds or 10 seconds. It's actually quite longer than that, so yes, let's not waste our time. The H here that I got is 0.9813 meter. I actually tried that already, so I can confirm that we can use that function in the exam room, but it takes quite a long time, so make sure if there's something like this, move to the next question first, because this will take a little long time and you might get panicked. Well, the calculator can do it, but you might get panicked from waiting it, like it's not working. It seems like the calculator just freezes, but I'm not sure your calculator is faster than mine or something, because like in this case we have a lot of power and it's not the normal power that we can solve it in the normal calculator. It's a fraction power, so yeah, it's quite hard for the calculator. I feel pity for the calculator as well. Okay, so now I get the number at 0.9813 is the normal depth here. So let's answer for A. Normal depth here is 0.9813 meter. So then we can move on to B. We only finish A. B here we have to find the fruit number. So now we get the H, the normal depth here. We can find the fruit number later. So for A equals to 2.771 from the upper part times X, right? And then minus 1.108. So here is 2.771 times 0.9. Oh, this is 9, right? Okay. Minus 1.109 meters square. The answer is, there are only some parts that I have pre-calculated it, so bear with me. Minus 1.109, 1.610 meters square, and then we can find a v, which is, we can use 1.5 over this number. I like to draw the line later, it's easier. 0.9315 meters square per second. So then we can find the hydraulic depth here. HD is equals to A over B, still the same. And A here, it's not the same as the previous one, over B here, but this one is the same. 1.6 square root of 3. It is from 2 times 0.8 times square root of 3. So this is 1.610 divided by 1.6 square root of 3. Answer is 0.581 meter. Then we can find the fruit number equals to U over GH D. So here the U that we got up here, I'm not really like used to V and U yet because I just switched from V to U. 9315 meters square per second. This is 9.81 meter per second square times 0.518 meter. See, it's much better than just drawing the line first. So the answer that I got here is 0.98. Oh, 9315 divided by 9.81 times 0.51. 0.39. Okay, so this is the fruit number. Why do we need to find the fruit number? You will see in the next question. So this is the answer. Fruit number for normal depth is 0.39. So now we finish question A. We're moving on to question C. So question C here, it's the critical depth that is defined. We want, as I'm showing here, oh, it's right here, very nice. So the fruit number equal to 1, it is the critical depth. So now let's go straight forward to that, because we're finding the critical depth and we're not finding the super or the subcritical. So now we have FR, the fruit number here, U over square root of GHD. Okay, then we can find okay, always a little bit tricky. Let's keep away right here. So now we want a fruit square. So fruit square would be Q square BS over G a to the power of 3, because right here it's a, right? So this will be out, g is right here, and it would be something, okay, h equals to a over bs. Q over a. So when this one, power of 2, we have here a2, 1 plus together it's a3, it's here. And b is from here because we already canceled the square root. So then we can find the something down here. So vs here is equal to 2 times h square root of 3. Why we are finding h again? Because we don't know the h. We need to know, we only know that the critical depth is inside the v, right? So we don't know what else is going to happen next. Okay, so a here is equal to 1 over 2 times h times the base, and we don't know the base, right? Like, we know that the critical depth here is somewhere in here, or here, or here, but we know that it's not right here, right? So then we can continue our calculation down here. So let's cancel this. We cancel everything. We're not canceling this one, we're canceling 2. Why did it just cancel h? It's 8 square root of 3. Yes, and then okay. fr equals to fr square equals to 1.5 square times 2 square root of 3h. Everything is over 9.81 times 3 root 3 h6, because this one here, it's like this, right? So it's like this, it's like this. So it could be this, because yeah, okay. Am I right? Yeah, time like this. So this and this becomes 3, so it's 3 square root of 3. Then we can find the h here by substituting fr square equal to 1. (4.5h). We don't have to use a solver for this one because it's quite simple, but solver can also do that for you. Why is it 5? Because it's an h, so we can finally cancel it out. We can only cancel it out if it's on the top and on the bottom. Don't cancel like me. Don't cancel like h, and then cancel like this. No, that's not fine. And then we can find the h5 here by 4.5 times, not times, divide by 50.974. So h equals to 4.5, h power 5. Zero 0.088228, so I'll just 83 meter 5. So now we're finding the h. It's the square root, not the root, square root, the root of power 5. We have a function here in the calculator. Wait, I have to find, okay, shift power 5 and inside is 0.883. Whoa. Answer is 0.6154 meter. So therefore, critical depth here is 0.6154 meter. Wow, this is a lot. It took me like 40 minutes to finish this one. Because it started at 3:30, 2:30, and I was there at 3:10. Quite a lot thing, but once we're ready, once we're ready finish this, we can know the patterns and it can be more easier later. So now let's move on to the next example real quick. I actually aim to finish 3 exercises in 2 hours. Is that fine? Okay, you can stop here and take a break and come back. Okay, so you can just pause here, but I'll continue to the next question here for you. So it is a prismatic channel again, but this prismatic channel, let's say something a little bit quite different, because as you can read it, it says wait, what is inch 1 in 50? So slope in 1 in 50 supposed to be 1/50, right? So in this case, it's quite different here. Yeah, it's not the normal slope that we can see, so it's 1 in 50. It's 1 in 50. Okay, the flow rate here is 2, and the flow depth here is measured from the lowest channel. So the lowest point of the channel, it's like here, right? Estimate the value of Manning ends. Why we find the n here? Okay, so we keep finding different things here. Usually we find the q or the u or something, but this case we're finding the h, and now we're finding the n. Okay, so we're finding a lot of things here. Then we need to find the depth of the channel at a flow rate of 3. So I guess this one is going to use a solver again, and find the fruit number, and D, state whether the channel slope is steep or mild. So steep is like this, or mild is like this. So it's based on the slope number for the flow rate in part B here. So I justify our answer. So basically, for A here, okay, I'll show you the picture, the diagram first, because in the actual example there's a diagram, so you might like, what is a diagram, like what will the shape of this prismatic channel. So I'm not gonna draw on this blank paper again. I have no capability in writing on the blank paper. See how neat it is to write on a squared paper. So now I'll draw it from, I hope it turned out well. It's a half circle. I hope you can interpret this image as a half circle. Does it look like a half circle to you? If it looks like a half circle to you, then it looks like a half circle to me. Okay. I'll draw a circle for here first. I don't know if GoodNote has the option to let you draw the half circle for you, but This is what the channel looks like. This is what a channel looks like without this part. Why? Okay. Nice, nice. Wow, I'm so smart. So smart. So this is center, and this is the lowest point here. I'm not gonna point the lowest here. So, somewhere. Okay. This is the radius. Come on. 0.6 meter. Okay, so we'll draw it. This is the half circle is right here. Okay, half circle is right here, so don't forget. Then we can proceed to the next procedure. So yes, we finally can get the answer, can get the diagram. So what is given in this problem? We have streamwise slope. So slope equals to 1/50. Okay, and then we only have this one, I guess. Okay, and flow rate is 2 cubic meter per second. Cubic meter per second. Okay, then we can see that A equals to 1/2 pi r squared, because pi r squared is, I'll write it down, area equals to 1/2 pi r squared. Because pi r squared is the whole one, right? But the semicircle is only 1/pi r squared, which is r is 0.6, right? So the answer is 0.5655 meter square. And then we can find the p, the parameter, which is not 2 pi because it's only half. So p here is only pi r, and it is equal to 1.885 meter. And then we can find the RH. So the RH here is equal to A over P. And for this A over P at 0.5655, as recommended from the professor, he told you should compute everything in the final step. But I'm just doing this to show you the things, right? So in the exam, you should substitute everything in the very final step of the calculation to avoid any missing number or missing digits. So this is, we get the hydraulic radius, and then we can use it in the Manning's equation. So in the Manning's equation, U is equal to square root of S over N times RH 2/3. Then Q equals to UA. So this we have 2 cubic meter per second equals to square root of 1/50. What is going on? You don't want me to draw a square root? 1/50 is 0.02 over Q, which is 2. Oh my god, I start to have place like a blank. Okay, time A. Wait, let me check a second. I don't know if this is right. Okay. Okay, this is N, right? Okay, sorry, this is N because 2 is already Q here. So then we find the N is equal to 0.02 times 0.3 2 over 3 here times 0.5655. Everything here over 2. The answer is 0.0179 meter to the power of 1 over 3 s. This is the Manning's n. So therefore n equal to 0 is the Manning's. And then we have to find the next part. But before going to the next part, I want to show you the alternative method for this one. So for the alternative method, it's like another method to do it. We can only just do V equals to Q over A, and it's I should write it down, right? So this is method 1. This is method 2. So U equals to Q 2 over 0.5655 cubic meter per second, and this meter cube. So 2 divided by 0.5655 equals to 3.53669, and everything here will be wait a second. Oh, we find the RH, right? So RH here is 0.3 times 2 over 3 here, 0.44 times 0.5655. Basically, we're just doing this. U equals to slope over n, okay, time 0.2, okay, and times 0.3, 2 over 3 times 0.5655. Okay, so the answer is 3.53669 equals to 0.02 or 0.2, okay, 0.02 times 0.3 power to 2 over 3 here times 0.5655. 0.6338 over n equals to 0.0117179 meter power 1. Okay, I don't want to call the units again. The units are so confusing. And then we can see the cross-sectional area. Oh, not the cross-sectional area. The Manning's S. But I think the method 1 is quite easier. Even though this one is shorter, but method 1 is quite, understandable. So it's more and more understandable. Okay, so sorry. It has no this part. It's only this part because we're finding the yield. So basically you want to reverse it or not reverse it. It depends on how you like to find things. If it's a reverse, then you can find it from the Q first. So you can find it from the U, and then you get the value U, and then you substitute the U, and then you find the N, or you find everything and then substitute and find the N in the final at Q, because Q is the given thing here. Okay, and then we can proceed to question number 2. Find the depth of the channel of flow rate of 3 meter cube per second. So in this case, we're going to do something quite, to do something quite a little bit similar to the previous one. As you can see, the 2 cubic meter square, the P here that we're finding, the P, the R, we're staying in the semicircle. But so 2 meter cubic per second is staying inside the semicircle. So if we want to increase it to 3, it's going to flow over the line of the semicircle. So you need to do something like plus h minus x. Yeah, that thing. Okay, so now we can move on to B. Oh, my sound is shaking. B. Okay, so we need to add some depth x here. We get h equals to 0.6 plus x. And then we can solve it. So basically it's the upper here is just a rectangle, right, if you look carefully. So this would be h plus this part here, it's 0. So this would be h. Yeah. And this is this is x. And all the way here is h plus x, or 0.6. H. Okay. This is x. This here is h equal to x plus 0.6. And this is 2 times 0.6, which is equal to 1.2. Okay? Yeah, so you guys are smart. You get everything else. We get area is equal to, sorry, my sound is already hoarse. Okay. Soon enough, you cannot hear my sound anymore. 1.2 meter x. I think I don't drink enough water each day. P is equal to 1.885 plus 2x. Why is it 2x? Yeah, you know the answer. Because this is x, right? And it's 2 side. 2 times x. Okay? So we find this, and then we can see the RH equals to A over P equals to 0.5655 plus 1.2x meter squared over 1.585 plus 2x meter. So everything here equals to u, the Manning's equation, square root of s over n times, I don't want to write everything yet. I know you guys are smart. You know what it is. 2 over 3 times, no more times. Okay, so then the Q equals to 3 cubic meter per second equals to square root of, please tell me how to write it without getting a parabola here, 0.02 over n, 0.0179. Yeah. The units are too long, so I don't want to substitute the unit here. Yes, but we all know that the value of the thing that we're finding is in meter, right? Yeah, you're smart. You guys are so smart. Times 0.5655 plus 1.2x over 5 over 3. Why is it 5 over 3? Because it is, the area is also inside this one too. So this is this one, yeah. And then we can find, oh my god, I already get tired of this. But you know, it's quite simple once you think that it's simple. Yeah, right? It's even simpler than the previous the pipeline thingy. So it's really simple. So the total depth here is 0.6 plus 8x, and you're finding the x here. Okay, so then we can find yeah, nothing else besides using the calculator to find your favorite thing here. I haven't done any pre-calculation yet, so you can do the calculation while I'm doing, and then we can check the number together. We're doing a mind, what am I talking? We're doing a mind test. Mm-hmm. 3 over 7.9 here. And then equals everything here. So I'm doing this one, 7.3 over 7.9. And it is equal to the whole thing here. This is a silent sound. It's not because it is silent, because I'm computing. I want to show you how to do it in Excel one day, not today, not in this video. Or you want it in the same video, you can tell me in the comment box below. But I know that you guys wouldn't reach this part yet, right? It's already 1 hour. And we haven't finished 2 questions yet. Okay. I'm waiting for the calculator to show the number. But yeah, the thing is that the calculator will surely give you the number. It's just that, you know, it might and might not. Okay, it might and might not, but it will. I'm saying that it might not is in case we're finding the theta sign, like something, right? But I don't think the professor will be that, will give us a problem that we have to find the angle, right? If finding the angle, I don't think we can use the solver, because I tried using the solver for solving the angle like many times, but I don't get a satisfied result. But okay, so it's gone. 0.1714 meter. So the total normal depth here is equal to 0.6 plus 0.1714 equals to 0.7714 meter. So this is answer B, and then we can continue to question C. So for C, we can see that they are asking for the fruit number, right? So the fruit number is, nothing hard. It's still the same. HD, which is the hydraulic depth, and radius. Hydraulic radius is not the same. Hydraulic depth is not equal to hydraulic radius. Okay, so now hydraulic depth is equal to I just noticed that the hydraulic depth is always the same. Oh, how can it's always the same? The formula, even it's not the same shape, but the formula is the same. Nice, I like it. I know you guys also like it too. So it's the area of the thing that we have solved. Where's the area that we have solved earlier? Yep. 0.5 here. And then times. Okay. Then, okay. I'll write it. Answer here is equals to 0.6427 meter. So we can find the fruit number. Fruit, F-R-O-D-U-D-E, not fruit, F-R-U-I-T. Fruit number is U over G H D. The resolution is HD, so it's a hydraulic depth here. Equals to 3 point. What is 3 point? Where is the answer here? Okay, so we're going to substitute the H that we found earlier. It's right here. Okay, so I'll use this number 0.02 over 0.0179 times 0.5, just got it earlier, 0.7712 2. Oh, okay. 2 over 3. So in this case, it's no. Square root of 0.2 times over 0.179 times overall here 0.7712 over not square yet. Can you guys tell me if there's like something that I can do it in on screen and show the calculation at the same time by not downloading the calculator, that expensive calculator. 3.889. What is this? meter square per second. And then we can see that this is um okay, so the fruit number that we get is 1.549. No value. I mean, no unit, no value. So the fruit number, no more test here. Fruit number at normal depth is equal to 1.549. So the next question, not the next, it is the last question they're asking. State whether the channel slope is steep or mild for the flow rate in part B. So we can see that simply we just have to tell them if it's the fruit number is in the critical or supercritical or subcritical. So it is, we need to say that the fruit number is larger than 1 or less than 1. So for D, fruit number equals to 1.549 is larger than 1, right? So it's super, not SY, super critical. So if it's supercritical, it means that channel slope is steep. So with subcritical, it's mild, but this is larger, it's steep. We already have made it past 10 minutes. So I'm considering we have to go to the next question, which would take around, should we? Okay, so let me see what is the next example. So as I remember, the next example, yeah, trapezoidal. Oh, we have the Chesy coefficient. Have we learned Chesy coefficient yet last week? I can't remember. Or yeah, we should wait until we study the Chesy equation first, right? Then we can continue later. Yeah, so I'll finish for today, and why am I being so silent? Yeah, I'll finish for today, and we have this long thing here. This one, you can see that it's 15 pages, so don't worry about the exercise. It will be a lot of exercise for you. So this is something like drainage area, like a grass waterway. And we have this one too, and we have this one too. So for sure we have a lot of problems. So we already done 2 out of 15. Oh, that's not 15, right? Because we already added 2 pages, so around 10 more. Okay, I'll say 10 more problems that will be posted later. And for this laminar and turbulent, we still have more, right? We have like 6 more. Or we have done it? Yeah, not yet. I almost forgot about like what is turbulent, what is the laminar, but yeah, of course. So we have 6 plus 10, so it's 16 more problems that we're going to solve in this week. Mm-hmm. So maybe this evening or tomorrow morning or Thursday morning and evening and Friday morning. So of course in this week I will promise to give you guys 16 solution to all the problems. So thank you so much. Bye bye.